All right, we're going to talk about one additional method for solving nonlinear equations. Again, we're looking at the same equation, f of x is equal to 0. Remember, the Newton's formula was like this. We had one estimate xi. To get the next estimate, you took xi minus the value of f evaluated at xi divided by the derivative of f evaluated at xi. Now, suppose you don't know the derivative of the function. Then what will you do? Well, we've already seen how to approximate derivatives of functions. Let's look at this diagram down here. Suppose this is my current guess. This is my current guess of the root of the function, and I want to get a better estimate of the root of the function. If I was going to use Newton's method, I would need the function value and the tangent line. If I don't have the tangent line, what I can do is find another x, find the value of the function at that point, and take the secant line. We've already seen that the secant line is very close to the tangent line. So instead of using the slope of the tangent line, which is f prime, I'm going to use the slope of the secant line, which is given by what you call a difference quotient. What we've essentially done is, in this formula where there's an f prime, we want to replace it with this difference quotient. Okay. So that's all we're going to have to do. We can start with our Newton's method and change the column, which has f prime, so that instead of f prime, it calculates the secant. So let's go back to our Newton's spreadsheet and see what we can do to modify it easily and get a secant formula. So let's go there. And I will go to my Newton. And I'm going to rename it to make sure I don't override it. I'll call this a secant. Okay. Now, what do I need that's different? Let me go and copy the formula that I need. The formula I'm going to use for the derivative is right here. So let me copy that. And I'll paste it here. Okay, and let's move this around a little bit. We're going to need that formula. And we also are going to keep that because the error is actually the same. So all I'm doing is I'm replacing f prime in this formula with this difference quotient here. The other difference is I need two initial guesses to get these two values of x. All right. So instead of one initial guess, I'm going to have two initial guesses. So I'm going to put a first initial guess, and then my second initial guess. Okay. And let's do the same function with the same root. Now we're not going to put minus sign here. Let me suppose that my first initial guess was 2.5. All right. So we're going to have to modify this spreadsheet to include two initial guesses. All right. So I'm going to actually go here. I'm going to click on this row, then edit, insert. Let's see, where can I insert rows? I guess it's not here. Let's look somewhere else. Let's see if insert. Oh, here we go. Insert rows. Okay. I want to put my first initial guess in this row. So I'm going to just put that here. It's in the middle because I changed the alignment, so I'm going to click there and put it on the right like the other numbers. All right, so now I have my two initial guesses. This is the initial guess here, and this is the initial guess here. All right, let me make this a little bit bigger so you can see what I'm doing. So I do have those two initial guesses. I'll make that also a little bit bigger. All right. Now remember what I'm doing here. I'm replacing my f prime column here with this estimated f prime. So I'm going to change this name. Instead of saying f prime, I'm going to say estimated f prime, or approximate f prime. I'll make it a little bit longer so you can see what it's saying. And I want to use the difference quotient here and put that in this cell here. Now I'm going to need these two values of x and these two values of f. So I'm going to have to put a value of f in this one here. I already have the formula for f here, that's cosine. So what I can do now is select these two cells and do edit, fill, up. Now I have all of the numbers I need to compute this difference quotient. All right, so I'm going to replace the exact derivative with my approximate derivative. My approximate derivative is f of xi, which is here, minus f of xi minus 1, which is the previous f of xi, close parenthesis, divided by xi minus the previous xi, close parenthesis. All right, so I have a new approximate derivative. All I need to do now is fill down in this column and replace the actual derivative with the approximate derivative. Edit, fill, down. All right, now it looks like there's a problem, but in fact there's not. The reason why I'm getting division by 0 here, that's what this means, division by 0, is my B15 minus B14, these two numbers are so close together that the program thinks it's 0. In other words, my root is already so accurate that I don't have to go any farther. So these divisions by 0 are not anything to worry about. Okay. My formula for error hasn't changed at all. I'm still computing error based on my results. Let me move this out of the way a little bit. And I still get these curves that show the error decreasing extremely rapidly. So that's really all I need to say about secant. It's very similar to Newton's method. The advantage, of course, is that you don't need to know the function, which is the derivative of the function you're trying to find a root of. That's it.